So yesterday we got through problem number 5. So we found that our object moves with constant velocity in the negative direction for 2 seconds, stops for 2 seconds, then moves with a constant velocity for 3 seconds at a velocity of 1.3 meters per second. Shown as a position versus time graph, we just chose an arbitrary point of 0 meters and went in the reverse direction for 4 meters for 2 seconds, then sat still at that position for 2 seconds, and then moved back in the positive direction for the same distance, the same 4 meters, but taking 3 seconds to do that. And for velocity versus time as a graph, we have our minus 2 meters per second for the first 2 seconds, 0 for the next 2, and then plus 1.3 at the end, which is what we calculated in our motion map. All right. So for the next one, we start with a written description. And in our written description, we learned that we have 2 objects. We've got object A and object B. So object A starts 10 meters to the right of the 0 position. So this must be referring to our motion map, and moves to the left at 2 meters per second. So instead of positive and negative, we have left and right. Object B starts at 0 and moves to the right at 3 meters per second. So what I'm going to do first to start with my problem here is I'm going to go ahead and identify what the distances are on my motion map. I think that that's what's going to help me the most. So I'm going to start with 0 meters, and it says I need to go to 10 meters. So 1, 2, 3, 4, 5, 6, 7. I don't have 10. I'm just going to draw them. 7, 8, 9, 10. So I'm trying to keep the same distance. There's 10 meters. 2, 4, 6, 8. And then I'm going to color code mine. I don't know if you guys are color coders, but I like to color code things. So I underlined object A with my purple pens. I'm going to do my purple dots for this one. So it says it starts at 10 meters. So I'm going to draw my first dot for object A. I'm going to make sure that I put plenty of labels here. Object A starts at 10 meters and moves to the left at 2 meters per second. If each dot represents 1 second, then that means that I'm going to draw a dot every 2 meters going towards the left. So we're going to go that way. There's my dots going to the left, and I'm going to draw lines that go halfway between the two, which is pretty easy because I've got the scale right there. So there we go. Here's t equals, I'm going to put it on top because I know I'm going to draw another line for object B underneath. This is handy too because I can use this to make my position versus time graph. All right, so object B is going to start at the 0 position and move to the right at 3 meters per second. So each second that passes, I'm going to have 3 meters of distance between my locations. 1, 2, 3, 4, 5, 6, 7, 8, 9. There we go. So and my arrows for this object are going to be going to the right. So there's my motion map. Next, I'm going to create my position versus time graph. So for position versus time, I'm not given distances over here. I could create them. I'm going to put my 10 up towards the top here. There's 10. Let's see. And I'm going to try to divide this into my 2 meter sections. There we go. It's got my 2 meter sections there. 2, 4, 6, 8. So when I draw my object A, my first dot is going to be at 10 meters. So when time is 0, I'm up at 10 meters. And then this helpfully draws 1 second interval. So after 1 second, I'll be at 8 meters. At 2 seconds at 6. 3 seconds, I'll be at 4. 4 seconds at 2. 5 back to 0. So there's my object A. I'm going to label it down here, object A, so it's extra clear. Object B is moving the other way. I'm going to start at 0 At 1 second, I'm at 3 meters for object B. So I'm going to estimate where the 3 meters should be. At 2 seconds, it's 6 meters. So that's where it looks like that's where they intersect. Oh, do they intersect there? Yeah, they do. Because that's where they're at the same place at the same time. At 3 seconds, he's at 9 meters. So he's past it. There we go. Object B. Lastly, I have my velocity versus time graph. I could figure out my velocities here. I know that my object B is traveling at 3 meters per second, and that is a positive slope. My object A is traveling at 2 meters per second. That's a negative slope. So when I come over here to my velocity versus time graph, if I had marks here for how fast I was going, 0. To find my +3, I would just go up to +3. That's for object B, so it's my orange marker. Object A is traveling at -2 meters per second, so that's going to be down here. I'm going to draw my purple line, object B. What questions do you guys have about number 7? You guys feeling okay with these? I can't see you, so if you're just shaking your hand or giving me thumbs up, like, oh, I can't see you. All right, number 8. It's our last one. Woohoo! All right, so for our last one, we're starting with a motion map. It says both objects begin moving at time equals 0. We need to produce a written description, velocity versus time graph, and a position versus time graph. So I'm going to use the same colors again, my purple and my orange. So here we have object A starting at 0 and then moving in the positive direction at 1 meter per second. So say object A starts at 0 meters and moves in positive at 1 meter per second for 1, 2, 3 seconds. Object B starts at 1 meter and then moves in the positive direction also at 1 meter per second. All right, so what does this look like as a graph? All right, well, object A, our purple one, I'll just put some marks here to help me. Object A starts at 0 and then each second moves 1 meter. So I've got 1, 2, 3 seconds worth here. So 1 second, 1 meter, 2 seconds, 2 meters, 3 seconds, 3 meters. So there's object A. And object A is moving at 1 meter per second for 3 seconds. So if I come down here, my velocity versus time graph, I'm just going to put a mark there for 1. There's my object A. Object B starts at 1 meter. So when time equals 0, object B is at 1 meter and then moves 1 meter for each second. So my graph for object B is going to look a lot like object A, except it's 1 meter ahead. Oops, object B. And object B is also moving at 1 meter per second. So when I put that on my velocity versus time graph, it's going to be in the same place. So they're both on the same line. I'm not even going to label them as the ones on top of the other. They're exactly the same. Does anybody have any questions about problem number 8?